So today we're going to be looking at different types of more advanced angles. But before we get into that, let's make sure we review the four basic types of angles that we should know already. So acute angles are angles that are less than 90. So they look like this. Okay, they're kind of squished angles, or like this. It's another acute angle. Right angles are equal to 90, so they make a sort of boxed corner shape, and they're usually designated by a right angle box. So when you see this little symbol right here, that means that that angle is going to be exactly 90 because it's a right angle. So they usually identify right angles with certain markings. And then obtuse angles are angles that are bigger than 90, so they look kind of more stretched out like this, or they might look a little bit less stretched out like this, but they're always still bigger than 90. And then straight angles are exactly equal to 180. Basically, they're just a straight line. So straight lines, their angle measurement is always 180 because they kind of make a half circle. If you were to measure the space between these two endpoints here, it would make a half circle arc. So that's why we call it 180 degrees for a straight line. And some people will say that straight angles are also obtuse. Some people will say that obtuse angles are only between 90 and 180, not exactly 90 or 180. But again, depends on who you talk to. For most people, if you say obtuse angle, they're going to say bigger than 90. So I guess you'd include straight angles in that as well. But that's a point of not really importance. So the important part is to know that acute is less than 90, right is equal to 90, obtuse is bigger than 90, and straight is equal to 180. That's the four key main facts there when we get into these more advanced angles. Another thing we're going to need to know is how to name angles, because we are going to be working with angles that are branching off of the same point, and naming them is going to be pretty important. So when you want to name an angle, you have one of three options usually. So if we look at this first angle here, I could name it angle BAC, because I'm telling it going from this point to this point to this point. That's getting me this space in between here. That's telling me the right angle, or the correct angle, I should say. Now notice here, A, the corner or the vertex, always has to go in the middle of the other two letters. So you always have to include the vertex when you're naming it, and it always needs to be in the center of the two other letters you're going to use. So to name an angle, you use one of the endpoints, the vertex, and then the other endpoint. Same thing every time. Now you could go backwards, and you could say it's CAB, and that is also okay, because I'm going C to A to B. The vertex is still in the center, so everything is good there. So BAC and CAB are the exact same angle, just talked about differently. But again, it's two endpoints with a vertex in the middle. You could also call this just simply angle A, because there's one angle coming off of this vertex. So when I say angle A, there's no ambiguity. There's no confusion that this is the angle I'm talking about, because there's only one angle or one point there, one point angle off that point. And when you have a situation like this, though, that's when this sort of naming becomes a little bit less useful. So this can only be done when the picture is like this, when you have a single angle off a single point. When you have something like this, if I said I want to know what angle A is, then we have a problem, because angle A could be this angle, which is coming off of A, or it could be this angle, which is coming off of A, or it could be this entire big angle right here, which is also coming off of A. So I'm not sure which angle A you're talking about if you just say angle A, which is why you can't. In this case, if you have multiple angles coming off of the same point, you have to describe it using three letters. So if I want this angle right here, I'd have to call that angle BAC or CAB. So I have to use the 3-point naming system for angles in this type of picture. This angle right here would be called DAC or CAD, either one. So this would be CAD, we could say. This would be BAC for this angle right here. And if I wanted the really big angle, so if I erase this here, if I wanted this big angle right here, I'd have to call that angle BAD or DAB if I wanted to. But I have to use this point, and this point to describe this big angle right there. So normally the 3-point naming system is what people usually use, but if you're a little bit lazy, you can use the 1-point naming system as long as the picture fits with that. And the reason we get on naming is because the angles we're going to talk about today are usually pairs of angles, not just one angle in particular. So the first type of angle we're going to look at are vertical angles, and vertical angles are kind of unique in that they form this sort of X shape. So vertical angles are two angles that form an X shape, and they are always going to be congruent to each other. So this little program here has two sets of vertical angles. It has red vertical angles, so top and bottom, two red angles are vertical, and it has the two green angles, also vertical. Because the red angles, this to this to this, forms an X pattern with the other red angle here to here to here. So they both form a set of vertical angles. And the reason that they're always going to be congruent is because if you notice, if I try to open up the top angle a little bit, the top red angle, if I open that up, then the bottom angle opens up the exact same amount. So now they're both 102 or 122. If I close the top angle up, the bottom closes by the same amount as well. So now they're both 33 or 33.47. So no matter what I do to the top angle, the bottom angle is going to mimic and mirror that the exact same way. The same goes for the side-to-side angles here. So if I open up this green side angle, then the other green angle opens up. If I close that green angle, the other green angle closes as well, the exact same amount. So the reason vertical angles have this congruency is because as one of the vertical angles changes, the other changes by the exact same way, and therefore they're always going to be equal. And again, the telltale sign of vertical angles is this little X pattern shape they form. So whether it be this X pattern or this X pattern or this X pattern, they're always going to form kind of this X shape, which gives them that congruency to them. Adjacent angles are the next kind, and they don't really have anything about congruency or anything like that. They're just kind of a way to describe a set of angles. So in this case, adjacent angles are angles that are next to each other. Again, adjacent means next to. And what that means is that they share a side. They share a line between them. So in this picture, which we saw before, this angle right here, angle BAC, we'll call BAC, that we'll say is adjacent. So ADJ will stand for adjacent. That is adjacent to its partner. Let me get a different color here just to make it a little bit more clear. That is adjacent to its partner, CAD. Does not mean they're congruent. In fact, most of the times they weren't, or it won't be, CAD. But it just means that they're next to each other, they share a side. So in this case, they both share, we get yet another color here. They both share this middle side, AC here. Both the angles come off of this line. BAC goes along that side, and CAD also goes along that side. So they may not be congruent, but they both share a side, and therefore they're both adjacent. And one telltale way you can tell if two angles are adjacent is that their naming will share two letters. So in this case, BAC, in this case, CAD. So they both share two letters, therefore they're both going to be adjacent, because that means they both share a side. So if you name angles using the three-point system, you can automatically tell if they're adjacent or not by looking to see if they share two letters or if they don't. The letters don't have to be in the same order, but one thing that does have to be the same is that the middle letter has to be the same between both angles, because again, they're both coming off the same point. So BAC, CAD. So they both share that middle letter of A, which is another way you can tell if they're vertical, or sorry, if they're adjacent. Now, vertical angles also share a middle letter, but they don't share the two others. So adjacent angles share both a middle letter and one other letter, whereas vertical angles, which we looked at before, will only share a middle letter. So it seems kind of confusing at first, but when you get a few practice into them, it becomes a little bit less confusing. It's, again, noticing the vertical angles make that X pattern, whereas adjacent angles don't make an X pattern. They just have two letters or two notations that are the same. They both share a side. Now, using these facts, we can tell some things about them. But first, we want to look at one other special type of adjacent angles, which is called a linear pair. So a linear pair is a set of adjacent angles that forms a straight line when you put them together. So in this case, we'll call this angle 1 and angle 2, which is another way of naming angles. So instead of using letters, if you have the ability to, you can just put a 1 or a 2 or a 3 inside the angle, and you can call that angle 1, and you can call this angle 2, 3, 4, whatever you want. So it's kind of another way of naming angles if you have the option. In this case, angle 1 is adjacent to angle 2 because they both share this middle side here. And angle 1 forms a linear pair with angle 2 because if you notice, the bottom of angle 1 and the bottom of angle 2 put together form a nice straight line. So a linear pair is adjacent angles that form a straight line with their bases. So in this picture here, we have kind of a sort of funky Y shape. Angle 1 and angle 2 are still linear pairs because angle 1 right here, its base forms a straight line with angle 2, with its base right here, a nice straight solid line. And same thing over here, this actually shows both vertical angles and linear pairs, right? Because there's an angle 1 here and an angle 2 here. They're both adjacent and they form this nice straight line, so they both make a linear pair. You could also say, whoops, make sure I get my eraser here. You could also say that this angle, angle 2, makes a linear pair with angle 3 because they form a nice straight line and they're both adjacent. And the same thing with 3 and angle 4 over here. Whoops. 3 and 4 would also make a linear pair as well. But be careful because 4 and 2, they don't make a linear pair. If I get rid of 3 here, they don't make a linear pair, but they are vertical because they make that X pattern with their sides. So 4 and 2 would not be adjacent. They would not be a linear pair, but they would indeed be vertical. So using these 3 facts, we can actually solve some problems involving angle measurements that we might not have been able to before. So using the fact that vertical angles are congruent, or vertical angles are equal, again, congruent just means two angles are equal in measurement. That's what congruent means. Or 2 geometric figures are the same, is the literal definition. If I have this picture right here, and I want to figure out what x is, I can look at this and say, okay, this angle right here is 56. This angle right here is 2x plus 10. They're also vertical angles, right? They make that little x pattern. So I have this angle right here makes an x with this bottom angle right there. So because they're vertical, I know that the top angle, 56, must be congruent or equal to the bottom angle, which is 2x plus 10. And because this is now as an equation, I can actually solve this. If I want to solve for x, well, I get rid of the 10 by subtracting it because it's a plus 10. So I get rid of that 10. I get 46 is equal to 2x. I want to solve for x. I'm going to divide by 2 to get rid of that times by 2. And I get 23 is equal to x. And now I've solved for x. So even though it didn't tell me outright, because I knew that vertical angles are always equal, I could set this up as an equation that I know how to solve, and then solve that equation using the steps that I know how to solve equations with. Same thing with the next one here. Even though they're side by side, these are still 2 sets of vertical angles because they make that sort of x pattern. So I could say the first vertical angle, 2x plus 7, is equal to the second vertical angle, which is 61. And I too can set that up as an equation to solve. So again, this is all revolving around the fact that I now know that vertical angles have to be equal in measure. Because if they're not equal in measure, then they're not vertical. So what I could do then is I can say minus 7, and I get 2x is equal to 54. And then I can divide that by 2 and divide this by 2. And I get the end result of 54 being divided by 2, which would give me a 27. So I've solved for x that way. So again, these first 2 problems here revolve around the fact that vertical angles are always congruent. Therefore, I can just set up an equation between the side I know, or the angle I know, and the angle I don't. I can set up an equation between them and solve that new equation to get my missing variable there. And we can do the same thing with adjacent angles as well, as long as they form a linear pair or as long as we know something about the angle that they're branching off of. So for example, in this picture right here, I have a linear pair, right? Because there's 2 adjacent angles and they make a nice straight line on bottom, so I know that they make a linear pair. And so what I can do is I can say, okay, because these form a line, if we remember back, what measurement do lines always have? If it's an angle measurement, a straight line is 180, right? Because it's going from here all the way over to here, so it kind of makes that half circle shape. So I know that linear pairs, like these two, 3x plus 40 plus, so that's this angle right here, So that angle plus this angle, which is 5x minus 20, these two angles together form a straight line, which is 180 degrees. That's what straight lines are. They're 180 degrees across. So now, if I want to, I can solve for x by solving this equation. It's a little bit bigger than my other two, but I can still solve for it. Because I can combine my x's, so 3x and 5x together, that makes 8x. 40 and minus 20 would make plus 20. Still equal to 180. I can then subtract 20 from both sides. And I get 8x equals 160. And if I divide by 8, I get x equals a solid 20. So adjacent angles take a little bit longer because their equations they make are a little bit bigger. But it's still the fact that this angle, my first one, plus my second one, form a straight line, which I know is going to add to 180. So if I know that they form a straight line, I can simply say this measurement plus this measurement is going to equal 180, and then work from it from there. I was using the things I know and putting them together as a math equation to solve it out. Now you do have to be careful because this right here is solved for x. If the question was find the missing angles, I would have to go one more step further because this does not tell me what the missing angles are. This tells me what the x is. This missing angle is 3 times 20 plus 40. 3 times 20 is 60. 60 plus 40 is 100. So that missing angle there is 100 degrees, which would be my answer for that missing angle. I wouldn't say that missing angle is 20 because it's not. It's 100. The piece that I found is 20, and I can use that piece to find the entire angle itself afterwards. Same thing for here. This angle isn't 20. This angle is 5 times my x, which I know is 20, minus 20. 5 times 20 is 100, minus 20 is 80. So that angle is 80 degrees. So when you have adjacent angles, you have to be very careful on whether they're asking you to find the variable, in which case you can stop right here, because you found the variable, or whether they're asking you to find the missing angles, in which case you have to use your answer and go back up to the original problem and solve for those two missing angles that are still there. Same holds true for this case. In this case, it's a little bit less obvious, but we still have two pairs of adjacent angles. But in this case, they don't make a straight line. They're not linear pairs. They're adjacent, but they don't make a straight line, so they can't make 180. But if you notice here, this box symbol, as we said before, means that this entire big angle, ABD, that entire big angle is equal to 90 degrees. But it's also split into two smaller angles, this angle here and this angle here. Well, knowing that, I can say that the top angle, 6x plus 2, plus the bottom angle, 4x plus 8, should be equal to the total thing, which is 90. So if I take this angle right here, and I add it to this angle right here, that should get me the entire big angle, which I know is 90. And I just kind of put that into a math form. I said the first angle plus the second angle is equal to the big angle, 90. Draw my line and get to solving. 6x and 4x make 10x. 2 and 8 make 10 equals 90. Subtract that 10 off because I want to get my x by itself. So I have 10x equals 80. And then divide by 10, and I get x is equal to just an 8. Now, in this case, again, I've solved for the variable, but I still don't know what these two angles are. I don't know the measurement of what this angle is. I don't know what the measurement of this angle is yet. To do that, I have to actually plug in my 8 to solve for it. So if the question was, find your missing angles, what I would do is I would go here and say, okay, 6 times x, or 6 times 8, plus 2. 6 times 8 is 48. 48 plus 2 would make this angle 50. And down here, 4 times x, or 4 times 8, plus 8. 4 times 8 is 32, plus 8 gives me 40 degrees. So my two missing angles would be ABC is 50 degrees, and CBD is 40 degrees. Which, if I check it, 50 plus 40 does make a right angle, and they say the big angle is 90 degrees, so that does check out there as well. So you can go back and check your work too, to making sure that they make the two adjacent angles make the bigger angle you're looking at. Same thing over here, 100 degrees plus 80 degrees gives me a nice straight line of 180 degrees total. So that's how we can use our more advanced angle types to solve more advanced angle problems. We figure out, are they vertical or are they adjacent? If they're adjacent, I can add them together to get the big angle that they're both made of. If they're vertical, I can simply make one angle equal to the other. So vertical angles is when you set one angle equal to another. Adjacent angles are when you set those two angles added together and then set that equal to one of the bigger angles that they're made of. A little bit more equation solving here too, so make sure you catch up on that. Otherwise, that's all there is to it, to these two new angles. Hope you enjoy the video. Have a good day.